Ever wondered why AI sometimes gets things so wrong? Like when a model confidently calls an Eskimo dog a Siberian husky, even though they're totally different. That's the problem vision language models, VLMs, face. They're super smart, but they don't always know when they're clueless. Today, we're diving into a breakthrough called ViLU, which teaches AI to recognize its own uncertainties, and why that's a game changer. Let's start with the basics. VLMs are like the Swiss Army knives of AI. They're trained on massive datasets of images and text, letting them do things like classify images or generate captions. But here's the catch, they don't know when they're wrong. Traditional methods like the maximum concept matching, MCM, score, think they're confident when they're actually confused. Imagine a student who's 100% sure about a wrong answer. That's MCM in action. So how do we fix this? Enter ViLU. This framework doesn't just look at the image, it also contextualizes the text. Think of it as a detective that checks both the suspect, the image, and the clues, the textual concepts. ViLU uses a clever trick called cross-attention, which acts like a spotlight, highlighting the most relevant parts of the text when analyzing an image. This helps the model spot subtle differences, like telling an Eskimo dog apart from a Siberian husky. Here's the magic. ViLU doesn't need to mess with the original AI model. It's a post-hoc solution, meaning it works on top of existing systems without changing their inner workings. It trains a simple binary classifier, like a traffic light, to distinguish between correct and incorrect predictions. And instead of relying on the model's internal loss, a technical term for error metrics, it uses a weighted loss function that's loss agnostic. That's a fancy way of saying it's super flexible, and works even when you can't peek inside the AI's brain. Imagine you're trying to teach a robot to cook. Traditional methods might say, hey, the recipe looks good. But ViLU would add, wait, did you check if the ingredients match the dish? It's about adding a layer of common sense to AI, making it smarter about when to trust itself. And the results? ViLU outperforms state-of-the-art methods on massive datasets like ImageNet, CC12M, and LAION-400M. Ablation studies show it's especially effective in tricky scenarios, like distinguishing between similar objects or ambiguous text descriptions. This means AI systems powered by ViLU are less likely to make costly mistakes, whether it's misdiagnosing a medical scan or misidentifying a stop sign. ViLU isn't just a technical win, it's a step toward more trustworthy AI. By giving models a way to acknowledge their limits, we're paving the way for safer, more reliable systems in everything from healthcare to autonomous vehicles. So what do you think? Would you trust an AI that admits when it's unsure? Let me know in the comments. And if you want more deep dives into AI's inner workings, hit that subscribe button. Until next time, stay curious. Hey everyone, welcome back. Ever notice how AI can be so smart, but also so clueless? Like imagine a self-driving car staring at a flamingo in a parking lot, completely confused. Or a medical AI diagnosing a rare condition with 100% confidence, only to be wrong. That's the problem we're tackling today. How do we teach AI to know when it doesn't know? So here's the deal. Vision language models, like Clip or Gemini, can match images to text. They're amazing, right? But here's the catch, they're not perfect. In fact, they can be overconfident in their mistakes. Think of it like a student who aced a test, but then insists the answer is correct even when it's wrong. That's where this research steps in. The team behind ViLU, that's Vision Language Uncertainty Learning, wanted to build a system that acts like a gut check for AI. Instead of just giving an answer, the model would say, hey, I'm not sure about this. But how do you teach a machine to recognize its own uncertainty? Let's break it down. ViLU doesn't just look at the final answer. It digs into the process, like a student who reviews their test to figure out why they got a question wrong. The researchers trained ViLU to analyze patterns in the model's internal thoughts, like how confident it is in different parts of an image or text. This way, ViLU can predict when the AI is about to mess up, even before it does. And the results? Mind-blowing. On datasets like ImageNet and CIFAR10, ViLU outperformed older methods by a huge margin. For example, while other systems had a 93.6% accuracy score, ViLU hit 99%, like moving from a B+ to an A+ in a high-stakes exam. Even when faced with super tricky tasks, like processing thousands of captions at once, ViLU stayed steady while others faltered. But here's the kicker. ViLU didn't need extra training data or complicated setups. It worked with existing models, meaning it could be rolled out in real-world systems without a complete rebuild. And in situations where the AI encounters something totally new, like a rare medical condition or a doodle, it's way better at flagging its own uncertainty. So why does this matter? Imagine an AI that can warn you before it makes a mistake. In healthcare, that could mean catching a misdiagnosis. In self-driving cars, avoiding a collision. It's not about making AI perfect, it's about making it wiser. This research isn't just about fixing errors, it's about building trust. Because when AI can say, I'm not sure, that's when we start to really rely on it. What do you think? Are you more confident in AI now, or still curious about its limits? Let me know in the comments, because understanding uncertainty is the first step to trusting technology. Stay curious, and I'll see you next time.